Okay, Bismillah. Students, we are going to learn something about the rational functions. Now, when I say something, so that is basically we will be learning how to sketch the graphs of rational functions. And then later on in the chapter, you will see that you will be able to determine that range of the function. Like if I change this y with the f of x, so then you can tell the domain and range of these given functions. Okay. Normally, when you have a function and you have to determine the range, so you can find the range if you people are clear about its x-intercepts, y-intercepts, and if there is any turning point on it. Okay, so when these we have these rational functions, if we are good at sketching their graphs, then it means we can tell many things about them. So now let's see if we can really learn how to sketch the graphs of rational functions. Okay. Now the rational functions are mostly discontinuous functions because if you look at this B part, or if I just take you back to your O levels where you have learned how to sketch the graph of y is equal to 1 over x, you must remember that it was like this. It was like this part over here, and this part over here. Now this is a discontinuous function because the moment you put your x equal to 0, your y approaches infinity. Now infinity is an undefined value. This is too big or too small to be represented on a graph. So we just show that our graph going upward or going downward when like approaching, when x is approaching towards this 0 over here. Okay. So this x equal to 0 over here has a special name. This is called an asymptote. Okay. And if I be more precise, this is a vertical asymptote over here. Okay. This is a vertical asymptote. So when you have to sketch a rational function, you must be aware of the about the asymptotes, that if there is any asymptote. Now look at these three parts over here. It says determine the equations of asymptotes of the curves. So like right now, the B part is the easiest one over here because this has its denominator, which is like, this is y is equal to x minus 2. So I can see that there is one x equal to is quite clearly a vertical asymptote. Okay, we can have the horizontal asymptotes if your given fraction is an improper fraction. So this is an improper fraction over here. Okay, so I need to convert this into the sum of a polynomial and a fraction. So this is x minus 2. So this is going to be 4x minus 8. So this is going to be like this. This is going to be 11. So this y can be written as 4 plus 11 over x minus 2. Okay. If your x is 2, then this is going to be, there is going to be a vertical asymptote, okay? And if this x minus 2 goes to infinity, this 11 over x minus 2, that approaches 0, then you're left with y equal to 4. Then this y equal to 4 is another asymptote, and that is a horizontal asymptote, okay? So this part B has got two asymptotes. One is this vertical asymptote, the second is the horizontal asymptote. Now let's look at the part A. In part A, we have, look at this part A. Now, if you look at this clearly, you can see that this part A, its denominator can be factorized, okay? So this is y is equal to 2x plus 3 over x plus 1 into x plus 2. So this is a proper algebraic fraction, so there is no division. We can't write this as a sum of a polynomial and a fraction. So this has clearly two vertical asymptotes. One is x equal to -1 and the other is x equal to -2. Okay. Similarly, if you look at this C part over here, 1C. Now this is y equal to x squared minus 2x minus 3 over x squared minus 2x minus 8. So you see, once again, this is an improper fraction. So I'll be dividing the numerator with the denominator. Okay. This is x squared minus 2x minus 8. So this is 1x squared minus 2x minus 8. So this is this, cancel, cancel. And this is 5. So this is going to be 1 plus 5 over. I think this can be factorized into x minus 4 into x plus 2. Okay. So its horizontal asymptote is going to be y equal to 1. That is the horizontal asymptote. And then there are two vertical asymptotes. Okay. These are x equal to 4 and x equal to -2. Since we have to learn how to sketch these rational functions, so we must be very clear about the horizontal and the vertical asymptotes. So let me see that if I have any question here where I have to sketch this. Yeah, question number 5. Let's do this question number 5, where we have to sketch this given rational function. So keep it like this. Okay. So let's see how to sketch the graph for this question number 5. Okay. Let me make some space here. Okay. This is this. Okay, so we are ready. So we have y equal to 3x minus 1 over x plus 2. Now I can see that this is an improper fraction. So we need to divide this into a polynomial and a fraction. So this is going to be 3x plus 6. So this is going to be -7. So this is same as 3 minus 7 over x plus 2. So when I want to draw this, let me have this as my y-axis. Here is my y-axis. Here is my x-axis, and I'll keep this x equal to 3 a dotted line over here. Okay, and then I have x equal to -2 over here. That is the vertical asymptote over here. Okay, so we have these two asymptotes over here. One is at y equal to 3. This is y equal to 3, and this one is x equal to -2. Do you have any question here, Bacho? So far? Okay, so there is no question. Now the next thing we need to know is that if there is any intercept, if I put y equal to 0, when I put y equal to 0, I get x equal to 1 over 3. So that means when y is 0, x is 1 over 3. So it is going to be somewhere over here. Let me call this point A. This curve will be passing through the point A, which is x intercept, which is 1 over 3 comma 0. Now when I put my x equal to 0, so I have y is equal to -12. So that means this is going to be here, somewhere over here. This is, let me call this point B. So this is going to be the y-intercept over here. Okay. Now, we have to see that if there is any turning point on it. Okay, so I'm going to differentiate this. This is easier to differentiate this version. Okay, so dy by dx is going to be 3's derivative is 0, and this is going to give me 7 over x plus 2 whole square. When I put this equal to 0, so that means there is no turning point. Okay, so guys, you see that you people must be clear about the asymptotes. Okay, and then you should be clear about the intercepts. Okay, When I say asymptotes, this includes both horizontal and the vertical. When I say intercepts, this is going to be x and the y-intercept. And then you must be knowing the turning points on this. Okay, so there is no turning point. Now, these 2 points are suggesting me that this part of the curve is going to be something like this, okay? And the other part would definitely be something like this. So this is the sketch for this given function 3x minus 1 over x plus 2. Do you have any question? Okay, one more question. Where we have to sketch this rational function. So we are guided in the A part that we write in the equations of the asymptotes. So the first thing that you have to notice that if this is an improper fraction, so this is not an improper fraction, so that means this is not going to have any horizontal asymptote, okay? Then we see that if the denominator is fully factorized, so this is basically y equal to 3 minus x over x plus 1 into x minus 1. So the equations for the asymptotes are going to be x equal to minus 1 and x equal to 1. These are both the vertical asymptotes, okay? Now, then he says, find the x coordinates of any stationary point. So let's find this derivative quickly. That is going to be x square minus 1 whole square, x square minus 1. Now you must be very good at this differentiation. We will not be saying what is my u, what is my v. So this should be very clear to you that how this is being done, okay? So that is going to be equal to 0. So we have minus x squared plus 1 minus 6x plus 2x squared equal to 0. So I have x squared minus 6x plus 1 equal to 0. Can someone quickly solve this through the calculator and tell me what are these two values of x? So we got these two values of x. That means we have the turning points at these values of x, okay? So now, these are normally, one is before one of the asymptote, one is the after the second asymptote, something like that, okay? So I am going to start sketching this. So I have here is my, no, let me use a darker color. I have the,
सर
yes, beta.
सर पीछे मैंने आपको उस दिन भी बोला था यहाँ पे पीछे लिखा हुआ है कि y का एसिम्पटोट जो है वो y इज इक्वल्स टू 0 है तो आप बता देंगे वो कैसे हुआ है
That is not required. I'll tell you, but I'll tell you. Just hold on, hold on. I'll tell you that we are not bothered here to determine that horizontal asymptote. I'll tell you, okay? Let me show these minus 1 and 1 over here. So this color would work for me. Yeah, this is one of the asymptotes here. There's 1 here, and this is minus 1 here. Okay, one of the turning points is add. This is 2, 3, 4, 5, 6. So we have a turning point at this somewhere over here. This is 5.83, and the other one is 0.172. 0.172 will be somewhere over here. Okay, this is 0.172. Okay, now next thing is we need to know, he is just asking us to sketch this. Now we should be having the information about any intercepts. Okay, let's do that. So when I put y equal to 0, when I put y equal to 0, I get x equal to 3. So I have here the 1, 1, 2, 3. Here is the, this is the, I mean, x-intercept, which is going to be, this is the only x-intercept. Let me just mark this 3 over here. This is the only um, x-intercept with us, okay? And then let's check if we have any y-intercept. If I put x equal to 0, then I have y equal to -3. So this is 0 minus 3. Yes, 0 minus, this is 1, 2, 3. So I have this, there is one more y-intercept over here. Now we have taken some values over here, x and y. I have seen that what is just before this -1, if it is negative or positive, and just before this one, so this is negative. So we have a turning point, which is 0.172, and this is, so the turning point would be somewhere over here, okay? So this curve would be coming from the divine infinity, touching this and then passing through this. This is going to go downward like this. Okay, so this is what is going to happen between -1 and 1. Now after 1, I have taken a value. I have seen that after 1, what is happening? 5.86. This is 5.86. So we have a turning point somewhere over here. Here is a turning point. Okay, and then we have the x-intercept, which is going to be 3. So this should be something like, can you tell me quickly, did I ask you to put that 1.1? Now, by taking some more values, I have it like, coming from this infinity, passing through this, going down like this, and then just creeping with this. Okay, so in fact, this turning point had to be over here. थोड़ा सा sketch के अंदर गड़बड़ हो गया. Just assume that this is your turning point, which is 5.86 comma minus 0.08. Okay, something like that. So this is going to be something like that. So for the last part, we missed that this at -1.1, this was positive, so that this curve had to be above this over here. Okay, so
Actually, in the book, they did not even show the turning point for 5.86.
they have to. This has to be shown. Otherwise, what was the use of finding this turning point?